Hey guys, in this video I'm going to show you how to program the shoelace formula into your calculator. So the shoelace theorem or the shoelace formula is just a really convenient way for finding the area of a polygon, a convex polygon, given the coordinates of its vertices. So if you know the coordinates of the vertices of a triangle, you can use shoelace to find its area. Same thing for a quadrilateral, pentagon, so on and so forth. So there's a lot of nice little applications of the shoelace formula. You might have seen this from your coach for NSML before as well. And this can be computed by hand, and there's a nice pattern to it, and you should know how to do this by hand. But on the calculator team, that's not a good use of your time. Same thing on written. The written ICTM contest is calculator allowed, so you shouldn't really be computing shoelace by hand. That's error prone and time consuming. So instead, we have this little nice sigma notation for how to write shoelace, and I'm going to show you how to program that into your calculator in such a way that we can find the area of a triangle, quadrilateral, pentagon, so on and so forth. So first thing we're going to do is turn on our TI-89 here. I'm going to go to Apps. Now I'm going to go to Program Editor, and I'm going to create a new function here. Now I'm going to change this over to function. I want you guys to name your variable shoe, but I already have shoe because I've already programmed it in, so I'm going to call mine lace for shoelace. Now our function is going to have two parameters. I'm going to say x chords, comma, y chords. What we're going to do is we're going to pass our function a list of x coordinates for our vertices, comma, a list of y coordinates for our vertices. Now they give us a little bit of code for free. We have function and end function there. Now we need some local variables. I'm going to do len for length. Basically just if we have a triangle, it's going to be 3. If we have a quadrilateral, it's going to be 4, so on and so forth. S1 is going to be for a sum that we're going to be computing. Area is going to be for our final area. XA and YA are going to be augmented versions of our X chords and Y chords. In the shoelace formula, you could see it here. We need a list starting from A1 to AN, and then we repeat again with A1 to get our shoelace pattern. And so what we're going to do in our program is we're going to define XA to be an augmented version. Basically, we're going to concatenate or join two lists here. So we're going to take our list of x coordinates, and we're going to define, we're going to extend that list with basically A1 right here. A1 is going to be x chords at 1. Now you guys don't have to become experts in writing programs in your calculator. That's not really my intention here. What I want to show you is that you can write useful functions in your calculator. So if you see something that just keeps coming up in NSML or keeps coming up on your written practice, what you can do is exactly what I'm doing right here, which is try to get that formula into a stored function in your calculator. Now let me show you guys a little trick here. If you want, you could use the copy-paste feature. So I'm going to extend x chords the same way that I extended, or sorry, I'm going to extend y chords the same way that I extended x chords. Now you could highlight any text you want, and then copy, paste, and change. So I'm going to change x chords to y chords here. So anytime you think that would make you a little bit more efficient, go for it. By the way, there is the chance that I'll have a syntax error somewhere in here. I'm programming this with you live because I want you to see that not everything necessarily comes out perfect every time you program it into your calculator. You would want to pre-program this before a contest. Okay, now this line of code says that I need to know the length of my array. I need to know if I have a triangle or if I have a quadrilateral, a pentagon, whatever. I need to know what this n value is for my shoelace, and that's what len is going to stand for. All right, So we're almost there. Now we just have to start taking a sum. So now I'm going to define S1 to equal my sum. I'm going to go to the catalog, and for you guys, you might not see it. You're probably going to be at absolute value or something. Just press up, and if you scroll enough, you'll get to a sigma notation for a sum. So there it is. Now what sum are we going to take? Well, I'm actually just going to take this formula that you could see at the bottom of my screen. I need a product there. Now I have my x-coordinates stored in the list XA, so I'm going to grab that. Now, no guarantees that I'm not going to make a mistake here. It's kind of the point for you to see me programming this live, and if we do have a bug or some sort of typo, we'll go back later and we'll fix it. Now, we need XA at I. I is just an index, so that's all that is. Same as the formula that you could see at the bottom of my screen. Now, we need to multiply that. Oh, sorry, do I need to close my parentheses? I do. I need to close my parentheses, and then we're going to multiply that by a very similar quantity, but for our y values. Now, what I'm going to do is I'm going to say, it's pretty likely that I typed this correctly, so I'm going to copy it after highlighting, and then I'm going to paste, and then I'm just going to change as appropriate. Now, if you look at the bottom of the screen, you can see I need ya at I plus 1. By the way, the square brackets there mean that we're extracting the I plus first element from this list of y coordinates. And then I did have to change this to a minus sign, and then I've got YAI there. Okay, so then let's see. Once I have my parentheses closed, which I do, my sum is going to be indexed over I, where I starts at 1 and goes through the length of my list, and then close parentheses. Now we're almost done here. The area is based on this sum. I just need 1/2 of the absolute value of the sum that I just defined. So I'm almost done. I'm going to define my area to equal, I'm going to put in 1/2 times the absolute value of the sum that I just defined. I think I pressed the second key there by accident. Let's try that again. There we go. The absolute value times that sum. And then finally, we're going to press enter one more time, and I'm going to tell the calculator what value to return, which is the area. And then once we're done, all you have to do is press second quit, and we're back at our home screen. And I have a couple values that I've already computed because I know that this is a correct shoelace right here. So here's my shoe function that I defined, and you could see that this is 1, 2, 3, 4, 5 vertices here. This is a pentagon, and it came out to an area of 30. I'm going to change it to lace because that's the function that I just defined, and crossing my fingers here that I get 30 again. I did, so no syntax errors. So I got very lucky there. If you have syntax errors, all you have to do is rewind in the video, and you could certainly see what you get. I could try this again for a triangle. So I'm going to try shoelace on a triangle. Now this triangle has vertices 2, 1, 4, 5, and 7, 8. So you could see here it's a list of x coordinates, a list of y coordinates. And when you're giving this list, it has to be in curly braces. So to get to curly braces, you already saw this happen when we were defining our shoelace function, but second parentheses gives you curly braces. So you give a list of the x coordinates, a list of the y coordinates in order so everything matches. And I'll show you that my new shoelace function that I named lace also works, because if I run it, I get 3 again. So guys, time for a little bit of debugging if you have any typos in your code. But if you ever need to go back and edit this, you just go to Program Editor. You go to Open now, because now you've created your function. You're going to change from program to function. And then you might have a list of a bunch of functions. But you can open, I'm going to open shoe, same as lace though, to show you again. You can go back in and edit this and fix any syntax errors that you have. You can certainly pause the video here if you need any of the code you see on the screen. or if I scroll all the way down, you could pause here if you need any of this code. We'll talk a bit more about how to write programs like this, where to find them online, and then what sorts of problems this function might be useful for. But the main idea is once you've defined the function, now it's in your calculator until you've cleared the memory, and you could just keep referring back to this function anytime you need it. On the ICTM written, on the calculator contest, this is going to make you a more efficient and fast problem solver, no matter what level you're competing at. Sophomores are going to find this useful for geometry, but really any level deals with coordinate geometry. So knowing the vertices of some sort of polygon and trying to find the area of that polygon. It's also good for working with lines because it's a great way to test for a set of collinear points. We'll talk more about that in some later problems.